Before moving on straight into the topic, guys and girls, I'd first like to recap a little bit on long division. This is so important because students even at university level who sometimes come up to me and say, "Sir, I forgot how to do long division." So let's go back to primary, the basic concepts. Simple as 7 divided by 3. So how do we do the long division here? The closest number in the 3 times table is 6. So 2 times 3 is 6, always a minus, and we have a remainder of 1 over here. Now, this is called the quotient. Sorry, not Q-O-U, is Q-U-O. So this is called the quotient. The 7 is called your dividend. Number 3 over here is called the divisor, and we have 1 as the remainder. So what does this tell us? This says that 7 divided by 3 actually can be expressed as the quotient plus remainder over divisor, and this can be rewritten as a mixed fraction to 1 1/3. So carrying this forward to algebra. Simple example, let's say we want to perform long division with this expression, x plus 3 divided by x minus 1. Same rule applies here. X plus 3 inside, you see whatever is on top here is in the inside, and this is the divisor, so it's on the outside. Now when we do polynomials, we always want to eliminate the first term. That's it. Just concentrate on killing off the first term. Elimination of x here. So what times x gives me an x? 1. So 1 times x is x, followed by 1 times minus 1 is minus 1. Now look at this, guys and girls. This is a minus here. Students have this bad habit of not writing brackets with a minus. Please have this as a good practice. Put a negative and open a bracket. Why? Watch what happens over here. X subtract by x is 0. So yes, I've eliminated my first term. But a negative makes it a positive 1. 1 plus 3 giving me 4 over here. So we have x plus 3 divided by x minus 1 can be expressed as the dividend, the quotient plus the remainder over divisor over here. Let us move on now to the first theorem for today, which is the remainder theorem, and it's going to be followed by the factor theorem. Let's say we have a polynomial px up to n powers. So this can be expressed as a0 plus a1x, a2x squared, and plus many terms up to an and x to the power of n. If I were to substitute a value of x inside the equation by letting, let's say, x here equals to k, and I do not get 0. So this implies that when I substitute x equals to k, I get some value here as r. Therefore, this is the remainder theorem. R is the remainder when p of x is divided by, you got to bring the k over, so this becomes the factor x minus k. Now this could be quite confusing in this form, so let us look at an example over here. Let's just take a simple quadratic function. See, I'm going to show you the analogy over here. Let's say we have f of x equals to x squared minus 3x plus 5. And I'm going to say when x equals to 1. Let's watch what happens here. I'm going to put inside the functions of f of 1, and this equals to 1 squared minus 3 times 1 plus 5, giving us 1 minus 3 plus 5 and we have 3. So this is what I meant when I put in k, I get r. In this case, when I put in 1, I get 3. And I said r is the remainder. So in this case, we have 3 is the remainder. Now, let's go to a more formal way of looking at this, or rather the long method. So I told you guys and girls, this is the remainder when it is divided by x minus k. So what I did, I brought the k over here, plus k, went over to the left hand side to become minus k. So I got to divide this expression now by x minus 1. So let's try. We have x squared minus 3x plus 5. Since x equals to 1, when I do the long division, it becomes x minus 1, just as I wrote x minus k here. So remember, the first term is what we want to eliminate. So I put an x. Why? X times x is x squared. X times minus 1 is a minus x. Put a minus. Do not forget. Please put a minus and open brackets. Make this a good practice. So x squared minus x squared has been eliminated. Minus and minus gives me a plus. So negative 3x plus x gives me a negative 2x, and bring down the next term, a plus 5 here. Next, I want to eliminate the minus 2x. So see, I put a minus here. Minus 2 times x is minus 2x. Minus 2 times minus 1 is a plus 2. Put a minus, open brackets, and now we solve. Minus 2x, minus and minus is plus 2x. There you go. We eliminated the 2x term. 5, negative and positive is a negative. So 5 minus 2 is 3. And I told you guys and girls, there you go. 3 is the remainder. So instead of doing a long division all the way, if you guys and girls understand what is meant by the remainder theorem, I do not have to do the long division. I just got to substitute the value inside and I get the remainder here as 3. This is just to verify. Through long division, you would also get the same answer. Next part, let's go on to the factor theorem. See, this is the same polynomial over here, up to power n. And let's say now, by letting x equals to k, when I substitute k into my polynomial equation, I end up getting 0. So if that happens, that means over here, x equals to k is a root, and x minus k is a factor. What does this mean? Let's look at an example now. Let's say we have got this equation, f of x equals to x squared minus 6x plus 8, and I'm going to say let x equals to 2. So watch what happens when we substitute x equals to 2 into this equation. So we have f of 2 equals to 2 power 2 minus 6 times 2 plus 8. So this gives us 4 minus 12 plus 8. 4 plus 8 is 12. 12 minus 12, we got 0. So that means this guy, this value that I substituted in, x equals to 2, is called the root. And if I bring the 2 over, x minus 2 is a factor. So let's cross check this by long division as what we did to the previous example. I'm going to take this polynomial here, x squared minus 6x plus 8, and I'm going to divide by, remember I've got to bring it over, I've got to divide by the factor, not the root. So we divide by x minus 2 over here. First step, always eliminate the first term here, which is x squared. So I need to put an x here. X multiplied by x is x squared. X times minus 2 is minus 2x. Subtract, open brackets. This eliminates, minus and minus is a plus 2. Plus 2 minus 6 is minus 4x. Bring down the plus 8 here. This got to be a minus 4. Minus 4 times x is minus 4x. minus and minus giving us a plus 8 minus open brackets, negative 4x plus 4x is 0, 8 minus 8 we have 0 remainder. See, we get the same thing. So what happens over here, I told you guys this guy is a factor. That means the dividend in here, x squared minus 6x plus 8, can be written as a product of these two, the quotient and the divisor, x minus 2, x minus 4. Let's check. I'm going to take x minus 2, x minus 4, and I'm going to expand. So basic expansion, x and x and 4, minus 2 and x, minus 2 and minus 4. So x and x gives me an x squared, x and negative 4 minus 4x, minus 2 and x is minus 2x, minus and minus gives me a plus 8. So we have x squared minus 4 minus 2 minus 6x plus 8, and see what happened. We got back this. So the dividend can be written when your remainder is 0. Whatever inside the dividend will be a product of these two. This will be a factor and the quotient will be the other factor. Why? Because remainder is 0. If remainder is not 0, you are not a factor. Now let's look at an Stpm level, a Form 6 level question over here. It's not likely for you guys and girls. USB. Let us now go to a Form 6 level, a Stpm level question. It's not likely for you guys and girls to just get a quadratic in Form 6. That's all done in your add maths in Form 5 and Form 4. So look at this. This is an x power 6 equation. You can anticipate something like this for Stpm, especially maths T. If fx equals to x power 6 minus 5x power 4 minus 10x squared plus k, find the value of k such that x minus 1 is a factor of fx. That means you've already given us a factor. For this value of k, find another factor in the form x plus a, where a is a constant. Now they've already given us a factor over here. So if x minus 1 is a factor, what did we learn earlier? This implies that x equals to 1 is a root. So since I know x equals to 1 is a root, when I input a root into my equation, I must get 0. So let's input that. This implies that f of 1 equals to 0. And what is f of 1? Replace all the x here with 1. So we have 1 power 6 minus 5, 1 power 4 minus 10 into 1 squared plus k, and this equals to 0. So now we've got an equation with only one unknown. We are able to find k. 1 minus 5 minus 10 plus k equals to 0. So over here we have k equals to 14. Now once we have obtained the value of k, replace k back into the given equation. So therefore now we have f of x equals to x power 6 minus 5x power 4 minus 10x squared plus 14. Now this is a trick question, and I want you guys and girls to go home and research something about this as well. Look at all the powers of x over here. They are all even. So I know one root is x equals to 1. The other root will be x equals to negative 1. The powers are even, so it occurs in a plus minus fashion. Why? Go and check it out. But let's check out what I told you guys and girls. Is it true? 1 gives me 0 because that's already mentioned to be a root. Let's put in negative 1 and see what happens. F of minus 1 is minus 1 to the power of 6 minus 1 to the power of 4 minus 1 squared plus 14. Negative number to the power of even always becomes a positive. Negative to the power of even is a positive. Positive times negative is a negative. Negative 1 squared is positive. Positive times negative is still a negative. And then I've got a plus 14 here. 1 plus 14 is 15. Minus 5 minus 10 is minus 15. And there you go. We have 0. So negative 1 is also a root. So what is the factor? So x equals to negative 1 is a root. Therefore, bringing over this, negative brought over to the other side becomes a positive. X plus 1 is the factor. And see, I have it in this form. We want it in x plus a. I have a x plus 1. So over here a equals to 1. Next example, given that fx equals to 4x power 4 plus 8x cubed plus kx squared minus 11x plus 6. Notice this is already a quartic, power 4. And they've given us two factors here, 2x minus 1 and x minus 1 are factors. Find the value of k. So we have an unknown here, k in the equation. We've got to find that unknown first and then factorize fx completely. Over here we are given two factors. I would go with x minus 1 because this doesn't have a fraction. So since x minus 1 is a factor, we can say, or we know that x equals to 1 is a root. So what is meant by a root? If I replace all the x's in the equation with 1, I get 0. Therefore, f of 1 must equals to 0, implying that 4 into 1 power 4 plus 8 1 cube k 1 squared minus 11 into 1 plus 6 got to equal to 0 because it's a factor, no remainder. So 4 into 1 to the power of 4 will be 4 plus this will be 8 plus with k minus 11 plus 6 equals to 0. Now we are able to find our value for k. 4 plus 8, 12. 12 minus 11, 1. 1 plus 6 is 7. So bringing over we have k equals to negative 7. Now of course some students would ask, there's another factor of 2x minus 1. Why can't I use that? You could, but it's longer. But just as an example, I'm going to show it to you over here. So if we were using 2x minus 1 as the factor, what is the root? Make it equals to 0. So we have 2x equals to 1 and x equals to half. So that now we have a fraction. It's doable, but it's not easy as a whole number. That means now, if I input half into my equation, I will still get 0 because it's a root. Let's check whether I'm able to get the same value of k by using half. So input this as 4, 1 over 2 power 4 plus 8, 1 over 2 cube k 1 over 2 squared minus 11 into 1 over 2 plus 6. So over here we've got 4 and half to the power of 4 is 1 over 16. 8, 1 over 2 power 3 is 1 over 8. So this is going to be half squared. So we're going to get k over 4 minus 11 over 2 plus 6. And again, sorry, it's got to be 0 because it's a factor. So let's leave the 0 over there. Let's cancel off. So this is 1 over 4. These two guys cancel off each other. And we've got 11 over 2 plus 6. So we have got 0 equals to 1 over 4 plus 1 plus k over 4 minus 11 over 2 plus 6. Simplifying the fractions, what do we have over here? 1 over 4 plus 1 is going to be
2 over 4.
No. 1 over 4 plus 1 is going to be 5 over 4. And then 5 over 4 minus 11 over 2 is going to be minus 17 over 4. Minus 17 over 4 plus 6. What do I have? Just press your calculator. (24 minus 17) is going to be 24 minus 17. Anybody? Is going to be plus 7 over 4 plus k over 4. 24 minus 17 is positive 7 over 4. So what happens over here? Bringing over the other side, we have k over 4 equals to minus 17 over, no sorry, it's plus 7 over 4, not 17. I wrote it right correctly, but I said it wrongly. So this is minus 7 over 4, and cancelling off the 4's, there you go, k is still negative 7 over here. So once we obtain the value of k, we input into the equation. So we have got over here f of x equals to 4x power 4 plus 8x cubed minus, k is a negative, so minus 7x squared minus 11x plus 6. So now guys and girls, I've got two factors over here. What are the factors? 2x minus 1 and x minus 1. Before I do the long division, I'm going to use both of these factors one shot. So watch what happens over here. Expand the brackets. We have got two factors, x minus 1 giving us 2x squared minus 3x plus 1. I'm going to perform long division with this entire fx and this quadratic factor. So we have over here 4x power 4 plus 8x cubed minus 7x squared minus 11x plus 6 dividing by 2x squared minus 3x plus 1. I'm just going to take this off so you guys don't get confused, because the quotient is going to be here. Now I'm going to get a 4x power 4. I've got a 2x squared here, because 2 times 2 is a 4. X squared and x squared gives me x power 4. 2 times minus 3 is minus 6. X squared and x gives me an x cubed. 2x squared times 1 is just a positive 2x squared. Minus, open bracket, do not forget, minus minus is a plus because these two have eliminated each other. 6 and 8 gives me a 14 x cubed minus 2x squared minus 7x, so we got a minus 9x squared, and bring down the negative 11x over here. So I want to get a 14, that means here must be a 7, and to get an x cubed it's got to be an x, so 7 times 2 is 14. X into x squared gives me an x cubed. 7 and minus 3 is minus 21 with an x squared and plus a 7x. Again minus, open brackets, first term eliminated. Minus and minus is a plus. 21 subtract by 9. What do I get? What's 21 subtract by 9? 21 subtract by 9. We have here 12 x squared. Minus and minus, minus and plus is a minus. Minus 7 minus 11 is going to be a minus 18x. And then I have a plus 6 over here. So to get a 12x squared, or a 12 rather, I have to put a plus 6 over here. 6 times 2 is going to be 12x squared. 6 and minus 3 is minus 18 with an x, and 6 times 1 is a plus 6. watch what happened over here, guys and girls. Everybody got eliminated off. We have 0 remainder. Why? Because this was a factor. We are expecting to get a 0 remainder. If you did not get 0 over here, your long division, something has been wrong. So what are the factors for this? So over here we know that f of x, since we have 0 remainder, would be the product of these two factors. Would be 2x squared minus 3x plus 1 into 2x squared plus 7x plus 6. And this factor was the expansion of these two. So I can further break down into two brackets, 2x minus 1, x minus 1 over here. This is a quadratic. I could break this up into another two brackets over here. 2x, x, I want to get a 7 over here. So what should I use? 1 and 6 or 2 and 3? Definitely I should use 2 and 3. So this is 3, this is 2. 2, 2, 4, 4 and 3 gives me a 7, plus and plus gives me a positive 6. This is the complete factor. X power 4, 1, 2, 3, 4 factors. So note something, guys and girls, this is a little bit out of what we are learning, but not so out. A lot of times when you're doing long division, I kept telling a minus with a minus inside the bracket gives you a plus. And you have been learning this since you started learning negative numbers in Form 1, Form 2. Did you guys ever wonder why a negative and a negative gives you a positive? Now in mathematics and as Stpm, as Form 6 students, please take the initiative to read up a little bit extra. Do not start memorizing things as formulas. It's time you guys start understanding why things work in such a way. There are two things in mathematics. One is called theorem. Not only two things, but you want to understand what is meant by a theorem and what is meant by a definition. Theorem are all those things that students usually call formulas. Like in a right angle triangle over here, I've got A, B and C, and we know Pythagoras holds A squared plus B squared has to equal to C squared. This is a theorem. Definition is like your operations itself. How do you define a plus operation? If your student asks why 1 plus 3 equals to 4, that is because this operation is defined in such a way. Now this goes way back to how, actually it goes back to farmers. Those were one of the pioneers who found out addition and subtraction. Why? Because they had cattle, they had chicken, they had ducks. When a cow gave birth, they got to add it on to their livestock. They had to come up with some kind of operation, and that was called addition. And if one of their cattle died, they have to come up with subtraction. So these are all the definition. Like a student, you can't ask me why we write number 5 like this. This is how you already define to write number 5. So definition we can't prove, theorems we can prove. Now where I'm coming from is I was talking about negative and negative gives you a positive. What is the definition of 0? I've got 5 goats and all 5 died. How many do I have left? 0. So anything subtract itself is 0. That means over here, watch carefully, we have some variable A. If I subtract the exact quantity, this definition is defined as 0 because it's its entire quantity. Now this is an equation. You guys and girls should understand what is meant by an equation. Whatever I do on the left, I got to do to the right. Let's say I've got 1 plus 3 equals to 4. If I'm going to put a plus 1 here, I have to put a plus 1 here. Only then it's balanced. 1 plus 3 plus 1 is 5. And then only I get 4 plus 1, which is also 5. So from this, I say let A equals to minus A. Everywhere where you see a, put it as a negative A. So this guy here becomes negative A minus, and this A also becomes a negative A. This is not A, this is 0, so he is not affected. Okay? So this is just a single term here. I could remove the brackets. So I have minus A minus with minus A equals to 0. And I told you guys, whatever I do on the left, I got to do on the right. I'm going to put a plus A here. and then minus a, minus with minus a equals to 0. I put a plus a here, I should put a plus a here. Now what happens here? A positive a and a negative a minus a is 0, so these two cancel off, and I'm left with minus and minus a. 0 plus anything is just this quantity, because 0 is no quantity by itself. And there you go, negative and negative gave you a positive. So if you guys understood 0, you would also understand why minus and minus gives you a plus. But this is one of the many ways to show this. But what I'm trying to do here is to encourage you guys as Form 6 students to read up more on all this. And somewhere along the lines is some of this proof will also help you answer your questions in your examinations. No knowledge is ever wasted. So with that, guys and girls, we are running out of time. Thank you very much for joining me on this video as well on e-learning with expert, and hope to see you all soon on my next upcoming video. Thank you very much.